With their high speed and bright colors, you may find it hard to believe that roller coasters had been around for more than 200 years. But since their beginning, the basic science behind roller coaster remained the same. It is the science of forces, energy, and motion, called physics. Like any other amusement park ride, roller coasters need energy to work. But it's what happened to that energy that makes roller coaster unique. First, the cars of a roller coaster are pulled to the top of a steep slope by either a chain system or another machine, pulling and lifting called a winch. These machines need energy to work, but this energy doesn't just disappear. It is changed and given to the cars of the roller coaster. What is this energy changed into? And how it transforms from the winch to the car? Hello guys, my name is Noor Fahad. I'm 15 years old from Dubai National School, and today we'll learn about types of energy. But first, what is energy? Energy is the ability to do work. For example, it takes us energy to play or even stand up. We have many types of energy which all fall into two primary types. The first type is kinetic energy, which is a moving object, and potential energy, which is stored energy. As I mentioned earlier, the kinetic energy of an object is the energy that it possesses due to its motion. It includes walking, falling, flying, and throwing. Kinetic energy is directly proportional to the mass of the object and to the square of its velocity. So the kinetic energy formula is half times mass times velocity squared. And the SI unit is joules. But if the mass has a unit of kilograms and the velocity of meters per second, the kinetic energy has units of kilogram meters squared per second squared. Let's take an example. For example, if an object with a mass of 10 kilograms is moving at a velocity of 5 meters per second, what is the kinetic energy? So as we mentioned earlier, the kinetic energy formula is half times mass times v squared. So what is given is the mass, which is 10 kilograms, and the velocity, which is 5 meters. So half times 10 times 5 squared. Don't forget the exponent, which is equal to 125 joules. Let's move on to the potential energy. Potential energy is the energy that is stored in an object. For example, a car that is parked at the top of a hill, or a yo-yo before it is released. The potential energy formula is equal to mgh. M represents the mass of the object, h represents the height of the object, and g represents the gravitational field strength, which is equal to 9.81. And it's sometimes referred to the acceleration of gravity. Let's take an example. For example, a 2.5 kilogram mass kept at a height of 15 meters above the ground. The force of gravity on mass 1 kilogram is 10 Newton. Find the potential energy of the object. So as we mentioned earlier, the potential energy formula is N times G times H. So kg, which is a mass equals 2.5 kg. And the height is 15 meters above the ground. So the h is the height, 15 meters, and the force of gravity is 10 Newton, so we will just write G was 10. And then we will easily times them without any squared. 2.5 times 15 times 10, which is equal to 375 joules. Don't forget the unit. Alternating between those two types of energy make for an exhilarating ride. Now the next time you ride on or see a roller coaster, whether just going up or down hills or spiraling through turns at 16 miles an hour, you'll now know a little more about how physics turn into fun. Thank you for listening and hope you enjoyed.